Hello. Ever feel like you are telling the computer exactly how to do something rather than what you want? Today, we'll explore two fundamental programming paradigms, imperative and declarative. Let's find out why declarative programming seems to get a lot of traction nowadays. Let's get started. Programming paradigms aren't just coding techniques, they're the fundamental blueprints that shape our solutions. They provide a framework to structure our code, manage data efficiently, and describe the processes in a clear and an understandable way, all of which make development easier. Ultimately, it comes down to choosing between defining how a task should be executed, the step-by-step process, or focusing on what we want the end result to be. With imperative programming, you are the director, giving the computer every single instruction. You explicitly tell the machine every single step to take, managing the state and the flow directly. This approach mirrors how computers have traditionally processed instructions, often leading to a more verbose code. So let's look at an example of coding the imperative way. And this is what it looks like, imperative programming at work. See how explicitly we are managing every part of the operation. Here we are manually dictating every iteration, test, and state change by looping through an array and checking each number. Then the condition checking, where we specify what constitutes an even number. And finally, the array manipulation. We explicitly add it to the array. While effective, imagine doing more complex scenarios with the same manual control. Let's transition into declarative now. Now, let's talk about coding with intention. Instead of dictating how to do things, we simply declare what we want to achieve. It's like ordering a meal and describing what you want, without having to micromanage the chef in the kitchen. After all, you only expect a dish, not the recipe. By abstracting away the low-level execution details, we can leverage powerful tools like higher-order functions and expressions to describe our intentions. So how does it look like in practice? Let's see the declarative way of finding those even numbers. With just a single expressive filter method, we achieve the same goal, finding even numbers, but with a single elegant line of code. We focus solely on what we want, and the language takes care of the how behind the scenes. The single method call is the abstraction we were talking about. A single method achieves the same result with way less code that showcases the contrast. Let's move on to a summary of both approaches. Imperative programming involves a chain of step-by-step instructions where the code state is constantly changing and the control flow is under manual control, often resulting in more verbose and error-prone syntax. Declarative programming, on the other hand, focuses on the desired outcome. It delegates the step to the framework itself, using immutable data that help avoid side effects and make debugging much easier, abstracting the execution details, and typically results in a more concise and readable code. The key takeaway here is not about choosing one over the other, it's about choosing the right one for the job. Imperative programming shines in low-level tasks, such as hardware interaction or memory management, where direct control over the machine is crucial, especially in performance-critical code. Declarative programming excels in large applications, as their focus is on the what rather than the how. It also provides better readability and a clearer intent, simplifying maintenance. Interestingly enough, many declarative APIs actually have an imperative implementation under the hood, showing how both paradigms complement each other. Ultimately, it's about understanding the trade-offs and choosing the best tool for the unique needs of each project. To summarize our journey through programming paradigms, remember that they are not about rigid rules, but about expanding our problem-solving toolkit. Imperative and declarative approaches aren't competing philosophies. They are complementary perspectives that work very well together. Imperative can be further refined into, for instance, procedural or object-oriented, and declarative into functional or reactive. The ability to shift from fine-grained instructions to high-level intent is what truly makes a versatile engineer. Thanks for watching. See you next time.